Okay, hi guys, we're back with lesson 2.6, Graphing Inequalities. This is video 7. I'm going to try to talk a little bit faster because this is kind of a long slide video, and so I'm going to try to get through it as fast as I can. So if you need to pause for just a minute to get your notes or to think about what we just talked about, then please do so. Okay, so let's get started. First thing we're going to do is we're going to look at graphing inequalities on the coordinate plane. Basically, they're the same as graphing equations on the coordinate plane. The only difference is rather than having a single line of ordered pairs that make the equation true, in inequality, there's a whole region of ordered pairs that make the inequality true. So we're going to use shading to show this. So a couple of things that you will remember is this is the less than symbol, this is the less than or equal to symbol, and here we have the greater than symbol, and here we have greater than or equal to. So if we have no equal to sign with it at all, then only things that are below the line, not the things that are actually on the line that are actually equal, make the thing true. So we use a dotted line to show that things that are not exactly equal to it, but it is everything that is below the line. For the less than or equal to, we use a solid line because it has the equal to. So anything on the line itself is a true statement because that's where the two sides are exactly equal. So that is a solution. So we use a solid line for that one. And then we would shade below. The greater than symbol here, we would use a dotted line because there is no equal to. And because it is greater than, we would use we would shade above. Here, a greater than or equal to solid line because the equal to sign is there, and we would shade above because it's greater than. Now, I'm going to go ahead and put a disclaimer on this right here. This little chart that you're looking at only works if an equation is in slope-intercept form. If it is not in slope-intercept form, you have to actually go in and test to see if a point is a solution to decide whether to shade above or below. And I'll kind of talk about that at the end with this last question that shows up here at the end. Okay, on this first example that we're going to look at, we are looking at one that's in slope-intercept form. Okay, I'm sitting here trying to move my screen on the wrong writing pad. So we've got it in slope-intercept form. We need to pick out the slope, and we need to pick out the y-intercept. The slope is 2, which we'll write as a fraction because it is rise, and this is positive, so we would go up, over run, which is positive, so we move to the right. We need to know where we're going to move up and over from. So we need a point, and that point is the y-intercept, which is -1. That's the point 0, -1 is the y-intercept. So we'll start by graphing the point 0, -1. Following the pattern after that so we can get in as many dots as we possibly can so we can draw a good straight line. So we go rise 2, run 1, and we'll continue that pattern rising 2 and running 1. Filling up as much of the grid as we possibly can. So we went as far as we could to the right, so now we also need to go to the left, but we need to reverse it. So we would go down 2 and to the right one, to the left one. Continuing that pattern until we run out of grid paper. Okay. We go back and we need to draw our line in now. What kind of line are we going to draw? We're going to draw a solid line. How do I know I'm going to draw a solid line? Because I'm going to go up here and I'm going to look at my inequality symbol, and it has an equal to sign with it. Anytime it has an equal to sign, that means anything on that line is a true solution. It is where it is exactly, the two sides are exactly equal to each other. So let's go in, pick up our line tool, and we will use a solid line. Connecting the dots, putting the arrows on both sides. Now, so we got our line drawn. That's where things are exactly equal, where the two sides are exactly equal. But we have anything that is greater not only can it be equal to, it can be greater than that. So we need to use our shading to do that. So we're going to pick up and do shade. Now the Y is the outputs right here. These are outputs. So the outputs have to be bigger than what we used to draw our line. Right here's our line. The output on that line right here at this point is 3. So I need to go to things that are bigger than 3. That's above. So we'll shade in things that are above. Now why did we shaded in above? Why did we choose above? Because we had the greater than symbol. Above, because of the greater than symbol. Okay, now let's spend just a minute talking about 2 possible solutions and 2 solutions that are not possible. Now remember I said this general rule right here only works if it's slope-intercept form. If it had not been in slope-intercept form, to know where to shade it is we would actually have to pick a point. So let's pick an easy point to work with right here. This one is the point 0, 2. So that's a pretty easy point to work with. Let's plug it in. The x is 0 and the y is 2. So we would have 2 is greater than or equal to 2 times 0 minus 1. So 2 is that greater than or equal to a negative 1, because 2 times 0 is 0 minus 1 is negative 1. Is that a true statement? Yes, it's true. So that is a solution. It's true. Okay? So if we were testing, we didn't just have our rules to follow up here, we would test that point, and because it was a solution, we would shade on that side of the line. If that had not been a solution, then the other side must have been the part that was that would have worked. Okay, let me show you that anything on the line itself. Let's pick a point that's on the line itself. This one right here. I know I'm kind of off right there, but that was the point. What's that? 3, 5. That's the point 3, 5. It is on the line. So it should be exactly equal. The 2 sides should be exactly equal. So we have 5 is greater than or equal to 2 times 3 minus 1. So this is 6 minus 1, which is 5. And 5, it is equal to 5. So that is part of the solution. 5 is equal to 5. That is true. So we have the solution 3, 5. Now, some things that are not solutions. Those would be things that are not in the shaded region. So let's pick something. Let's go up here to red since it's not a solution. Let's use this point right here. That's the point 3, 0. 3, 0. So with 3, 0, we plug it into our equation. And we have 0 is greater than or equal to 2 times 3 minus 1. That's 6 minus 1. That's 5. Okay? Is 0 greater than 5? No, it is not. That's not a true statement, so it is not a solution. We could choose anything in that white area. It would not be a solution. Let's choose this one. Let's go down here to 0, negative 4. The point 0, negative 4. Let's test it. So the y is negative 4. The x is 0. So we have 2 times 0. Sorry about the dogs in the background. For whatever reason, they have decided to go crazy. So 4. Is negative 4 greater than negative 1? No, it's not. So that one is not a solution, and that was the ordered pair 0, negative 4. It was in the white area, so it's not a solution. Okay, let's go one step further. Let's take it to where we have an example where it's not in slope-intercept form. Let's remember our general rules that we were talking about only work when it's in slope-intercept form, so let's put this thing in slope-intercept form. So we're going to take and we're going to solve for y. We're going to get y by itself. So we need to get rid of let's do it over here on this side. So we have 3x plus 2y is less than 8. Got to get rid of the 3x and we got to get rid of the 2. Let's get rid of the 3x first by subtracting, so it will go to 0. Do it to one side. Have to do it to both sides. So we have 2y is less than 8 minus 3x. Y then is being multiplied by 2, so to get rid of multiplying, we divide, and remember we're going to divide the whole side, so we're going to break it apart and do each part separately. 8 divided by 2 is 4, and we'll leave the slope as a fraction, so it would be negative 3 over 2, and x. So, to graph this, the b is negative 4, or not negative, but positive 4, so that's the point 0, 4. And the slope, the y-intercept, is a negative. Please be careful with your signs. I often forget them too, so double check and make sure that you are going to have a line that's sloping down. So we go up here to the y-intercept, 0, 4. There we go. And we go down 3 this time, and to the right 2. And we'll continue that pattern. 1, 2, 3, 2, and 1, 2, 3. Whoops, 1, 2, 3, and 2. Okay. This time, what kind of line are we going to draw? This time we're going to draw a dotted line. Sometimes I'll look at my handwriting and just laugh. Okay, so we're going to draw a dotted line. Why are we going to draw that dotted line? Because no equal to sign. Okay, it was only less than. So we'll go up, pick up our line feature, doing that dashed line here. Negative slopes going downhill. And where are we going to shade? We are going to shade, it's less than, right here, less than. So it's less than, so we're going to shade below because below is smaller. And it's because it's a less than symbol. Picking up my shading tool, highlighter here. So here we go. And we have everything that's below. I'm trying to be fast here so you don't have to listen forever. Okay, now we got to show some solutions and some non-solutions. So if this had not been in slope-intercept form when we graphed it, then we would need to test. So let's pick up a point to test. Let's pick a color. Let's say we choose, let's say if I can get my pen, I will be happy. So let's say we try a green one here. We want it to be a solution. So this one right here, that's negative 1, 1. It's in the shaded region. Should be a solution. Let's plug it in. 3 times negative 1 plus 2 times 1. We're going to calculate that, and we hope that it's less than 8 because it's in the shaded region, and it should be a solution. When we calculate that, that's negative 3 plus 2 is a negative 1. Negative 1 is definitely less than 8, so that is the solution. And that was the ordered pair, negative 1, 1. Then we're going to go up, find another one that is a solution. So 0, 0, that'll be really easy to test. So let's try 0, 0. 0, 0, x is 0, y is 0. So 3 times 0 plus 2 times 0 is that less than 8? Well, 0 plus 0 is definitely less than 8. So 0, 0 is a solution. We could go for, there's an infinite number of points that would actually work there. Now let's find something that's not a solution. I want to first go to something that is in the white area, something that's not shaded in. So that point right there, which is 2, 3, 2, 3 should not be a solution. So if we plug it in, we'll plug 3 times 2 plus 2 times 3. That's 6 plus 6. And it should not be less than 8. 12 is not less than 8. it is not a solution. Okay, sorry for the pause. I had tried really hard to try to get this video completed in the 15 minutes that I have, and I was not able to do so, so I had to pause it and go ahead and finish up the video and edit the two things together. So we had just been testing the 0.23. I plugged it into our equation right here, and we came up with 12 is less than 8. That is not a true statement. So the ordered pair 2, 3 is not a solution. So if I were having to go up here and just test to see where a solution was, this was not a solution, so I would not have this side of my line shaded. This side of my line should be shaded. Okay, then I want to take a minute to talk about the fact that this is a dotted line. This is a dotted line, so that means that things that are actually on that line are not solutions. This is the ordered pair 0, 4. 0, 4 is on the line. So when I plug it in, it's a dashed line. It should not make a true statement. Let's check and see. So the x is 0, so we have 3 times 0, plus the y is 4, so that's 2 times 4. And we want to know, is that less than 8? Well, that's 0 right there, plus 8. Is 8 less than 8? No, 8 is equal to 8. And that doesn't have the equal to sign with it. So that is not a solution. So we would write in the ordered pair 0, 4 is not a solution. Okay, the next thing that you have on the slide, the next slide is, you try, I think. It is. So take a few minutes, make sure you follow the rules that we just went through, graph that inequality, and make sure, because it's an inequality, you show all solutions by using shading in there. And I will see you at the next video. Only one left. Thank goodness.